Algebra 1, Common Core, Unit 7, Section 2, the axis of symmetry. The previous video was discussing about how to graph quadratics given a equation and a domain, and basically what I showed you is that all you have to really do is type this into your calculator and then set up your table to mirror this. But even if you're not given this domain, you can kind of move your table and your calculator around until you see the pattern where you see numbers starting to repeat. The one number that doesn't repeat, that's your vertex, and that's going to be your middle point. And so then it's usually 3 points above that, 3 points below that, or whatever you can fit on the graph. It's not a rule that it has to be 7 points like this. So what we're going to see in this is we're going to be given quadratics like this, but there's no domain attached to it, and we still need to figure out where to graph it. And one of the ways we're going to do that is using something called the axis of symmetry. And so the axis of symmetry is basically the line that cuts the graph in half in the middle, and it has a symmetrical relationship to it. So the parabola that you're used to, that we've been talking about now, y equals ax squared plus bx plus c, is symmetrical about a line called the axis of symmetry. And so what we're saying is, if we look at our parabolas here, you can draw a line that right down the middle of it that basically slices it in half. And you get a mirror image of itself. Like you see, every point is kind of a mirror image of itself across this line. If we go back to one of the ones that we drew in the last video, like I could graph this axis of symmetry. I use a pretty bold purple line to show you what I'm talking about. Right smack down the middle. It's pretty easy to know where it goes. And one of the things that we know where it goes is it's going to go through the vertex, because the vertex is the middle of the graph. So the axis of symmetry is very related to the vertex, and that's what it's saying here, that the axis of symmetry passes through the vertex. And so its equation is the x value of the vertex. So I'll show you what I mean. Now, first of all, remember, vertical lines are different than all of the other linear equations. They don't really follow y equals mx plus b, because they don't have a y, they don't have a slope, and they don't have a y-intercept. At least unless it's completely on the y-axis, then it has every y-intercept. But for our purposes here, you can say it doesn't have an m, it doesn't have a b. The slope would be considered to be an undefined slope. Right? A zero slope would be horizontal, but an undefined slope is vertical. So vertical lines have the x equals a constant equation, like x equals -2, and that's just a vertical line crossing -2. So it's the one linear equation that has, only the x-intercept. And so there's actually an equation, there's a formula for the axis of symmetry, and that's right here. X equals, and it makes sense that it's going to start x equals, because what we're talking about is it is a vertical line. So it's an x equals -b over 2a. Now, what's with the b and a stuff? Well, remember, your quadratic is ax squared plus bx plus c. So the numbers in a quadratic, there's 3 numbers. And this is going to become real important for other things like the quadratic formula. Just like y equals mx plus b, like we would call the slope m. Well, the number in front of x squared we call a. So in this case, when there's no number in front of x squared, that means it's a 1. So in this case, a would equal 1, b would equal 4, and c would equal 3. And when we talk about a, b, and c, we're just talking about the numbers. A and b are coefficients, and c is a constant. But sometimes people see b is 4x. B is not 4x. B is just 4, the coefficient of x. So a, b, and c don't have variables. They just have numbers. And they're, kind of working around and attached to the variables. So -b over 2a. So in this case, we said a is 1, b is 4. This formula doesn't use c. It just uses a and b. So a is 1, b is 4. And again, that's, said here, a is 1, b is 4 for the quadratic shown above. So x equals -b. Now notice that it's not b over 2, it's -b. So you got to negate b, so opposite sign of b. So when b is 4, -b is -4. Now if b was negative, then -b would be positive. -b is like change the sign of b. Over 2 times a, so 2 times 1 is 2. And then this reduces down to x equals -2. So the axis of symmetry here is x equals -2. And that's what we see drawn in this graph, x equals -2. Not only that, when we look at the coordinate of the vertex, the x value of the vertex is -2. So the axis of symmetry is the x value of the vertex. And that's really probably the thing you got to emphasize the most here. The axis of symmetry is the x value of the vertex. Because once I have that axis of symmetry, I can algebraically plug in x equals -2 into, remember it was x squared plus 4x plus 3, the original equation. So if I replace my x's with -2, I get -2 squared plus 4 times -2 plus 3. -2 squared is 4. 4 times -2 is -8. Plus 3 comes out to be -1. And that's the y value of the vertex. So we can algebraically get the axis of symmetry and the vertex. And then once I know where the middle of the graph is, I can figure out that domain just by saying, all right, well, if -2 is the middle, I could go kind of 3 above that, 3 below that to make it a domain. But your calculator can do most of that for you. So let's look at a couple practice questions. Excuse me. So for each quadratic function given, determine the equation of the axis of symmetry and the coordinates of the vertex. We want to do this algebraically. We could check it on our calculators, but let's first try to do it algebraically. What we need is the axis of symmetry formula. X equals -b over, there's a b, 2 times a. And remember, this formula will not be given to you. This is something that needs to be memorized. Commit it to memory. So you need to know what a and b are. Looking at this, I could see that a equals 1, because that's what's in front of x squared, and b equals -4. And I'll write c equals 1 also, but really we don't need c. So plugging this in, I get x equals -b. Remember, and that's probably the thing that people are going to mess up here. Now, b here is -4. But if I negate -4, remember a negative times a negative or, minus a negative becomes positive. So this is actually going to be +4 over 2 times a. A is 1, so it's just 2 times 1 is 2. So I get 4 over 2, and 4 divided by 2 is 2. So that's the axis of symmetry. I'll write AOS sometimes. Axis of symmetry, we get x equals 2. Don't forget when you're writing the axis of symmetry to write x equals. It's not, the axis of symmetry isn't 2, it's x equals 2. It's a line. Don't forget that the axis of symmetry has to be an equation. Determine the equation of the axis of symmetry. It's not 2, it's x equals 2. It's the whole thing. Then to find the vertex, what we can do, again, I can kind of cheat and just use my calculator, type this in, and then look in my table to see when x is 2, what is y? What goes with it? But if we want to do it algebraically, what we could do is we want to now do f of 2. I want to know what happens when I plug in 2 for x. So instead of x squared, it's going to be 2 squared minus 4 times 2 plus 1. Again, I'm just replacing these x's with 2's. You can put the 1 in front if you want. 2 squared is 4. -4 times 2 is -8 plus 1. 4 minus 8 is -4 plus 1 is -3. So that means my vertex is the 2 I put in and the -3 I got out. Okay, let's look at another example. -2x squared plus 8x plus 2. Again, my a here this time is -2, and my b is 8. My c would be 2. Again, c is not involved, but a, b, c. So x equals -b over 2a for this one. It's going to be x equals -b would be -8, the opposite sign of b, over 2 times a, -2. So it's a -8 over a -4. And remember, when you have a negative divided by a negative, it's going to come out to be positive. So -8 divided by -4 is +2. So I have another axis of symmetry that's x equals 2. It's the same as last time. And then this time when I plug it in for f of 2, -2 times 2 squared plus 8 times 2 plus 2. It's -2 times 4. That ends up being -8 plus 16 plus 2. So I'm going to get a different vertex here. -8 and 16 is 8 plus 2 is 10. So our vertex for this one is 2, 10. And again, the axis of symmetry is the x value of the vertex. Excuse me. All right, so Now, how is this going to help us with graphs? Let me just erase all these little stray marks. Well, given this quadratic, I want to graph it. I'll probably skip that bottom one so this video doesn't go too long. So last time we were given a domain in the previous video. This time we're not going to do that. Now, what we're going to do is we're going to use our axis of symmetry to help us figure this out. So again, the axis of symmetry formula here is negative b divided by 2a. X equals negative b over 2a. A is 1, b is negative 4, c is negative 3. So this will be x equals positive 4 because it's negative b, and when you negate negative 4, it's like negative, negative, right? Negative 4 is a positive 4 over 2 times a is 1, so we end up with 4 over 2, again 2. So there's another axis of symmetry where x equals 2. Sorry, I didn't realize they were all going to be the same. It's not always x equals 2. Well, you know, if we wanted to do our table like we were doing in the last video, a good rule here is that if that's axis of symmetry is the middle, and if I want to draw that x equals 2, that would be a vertical line crossing 2. So that's where my axis of symmetry is going to be. So that means my parabola is going to be perfectly centered on here, but where is it going to be exactly, I still need to figure out. But what we could do is if you kind of take that axis of symmetry and plus 3 and minus 3 to it, I'll get a reasonable domain to work with. If I add 3, that'll bring you to 5, and if I minus 3, that'll bring us to, sorry, these boxes are annoying. That'll bring us to negative 1. Whoops. Having some tech issues. Hold on one sec. Okay, sorry about that. The Bluetooth on my pen is acting up, so I'm going to have to try to finish this video with the mouse. But so anyways, if you add 3 to it, we'll get 5. If I minus 3 to it, it'll be negative 1. And so that'll give me an idea of how I should set my table up. Like we should work with, you know, starting at, wrong side, starting at negative 1 and going all the way down to 5. And so I could look at my table for these values, you know, because if the axis of symmetry is 2, that's in the middle. And I could plot, you know, 3 points above it, 3 points below that, and that's going to be these values. Again, I could use my graphing calculator or that website I showed you in the last video, I think called Desmos, desmos.com, where I could type in x squared minus 4x minus 3. And it's in these settings up here that you can, you know, that's already set up, but I could get the table to pop up and stuff like that if you click with these. But notice that the 2, the x value of 2, that's my vertex, and like I said, 3 below it, 3 above that. I could plot these points, I could get these values in my calculator, and I could graph this function now that I have these. So let's see, that's negative 1, 2. So let me try to plot these points. Sorry, it might be a little sloppy. So negative 1, 2, and 0, negative 3, 1, negative 6. All right. 0, negative 3, 1, negative 6, and then be 2, negative 7. Notice that my vertex is on the axis of symmetry, and then my pattern repeats back up the other way. And I'm getting all these values again just from the table in my calculator. And this is going to be super sloppy because I'm doing it with the mouse instead of a pen. Sorry about that. Promise I'll get the pen back up running for the next video. But that's it. So it's really the connection of the axis of symmetry will tell you where the middle of the graph is. And I could plug in that 2 to get my vertex. But, you know, the 3 values to the left of it and the 3 values of the right of it is a very good domain to look on your calculator. But you see that pattern and everything like that. Here your vertex is on your axis of symmetry because it goes through it. All right. That's it for the axis of symmetry. Sorry for the long video on the tech problems. See ya.